Hello viewers, welcome to Fame Global Academy, and I'm your favorite physics teacher, Fred Mark. In our last class, we talked about force. I would say the change of uniform motion in a straight line or a body at rest. And we talked about the two types of force. We said the contact force and the field force. We gave example of contact force. We said push, we said pull, we said tension, we said frictional force. And we also gave examples of contact force, which are magnetic force field, electric force field, gravitational force field. And then we went ahead to talk about friction, which is an example of a contact force. And we said friction is an opposing force, or a force that tends to produce motion, a force tending to produce motion. And we also talked about the different types of friction, the two types of friction, which is the static friction and the dynamic friction. It was properly explained in our last class. And we also talked about that friction is a vector quantity. And we said it also exists in the three states of matter, which is the solid, the liquid, and the gaseous state. And we talked about also the laws of solid friction. This exists in the three states. And we gave some laws of solid friction. And then we said about the last one, which we said that force is proportional to normal reaction. Force is proportional to normal reaction, where F is equals to mu R, where mu is F over R. Mu is the coefficient of friction, F is the force, and R is the normal reaction. But in a situation where, and remember we said that the mu has no SI unit, it has no SI unit, but in an inclined plane, take for instance something like this, an inclined plane. The frictional force on an inclined plane is now mu is equals to F over R, where F is mg sine theta, and then mg cos theta, which is equals to tan theta. So in an inclined plane, the frictional force is mu is equals to Fr, and F is mg sine theta. Mg is mass times gravity. The mass times gravity. Because on an inclined plane, the force of gravity is holding the body from slipping out. The frictional force there is mu F over R for mg sine theta, mg cos theta, and then it's equals to tan theta. Then we did some calculation on how to solve problem involving friction using the formula mu is equals to Fr. Remember, your mu is the coefficient of friction that has no SI unit. Right, today we'll be talking about simple idea of a circular motion. Simple idea of a circular motion. Now, an object that is moving with a constant speed. An object that is moving with a constant speed in a circular path. An object moving with a constant speed in a circular path is moving with a uniform circular motion. I repeat, an object moving with a constant speed in a circular path is moving with a uniform motion, uniform circular motion. And there are objects that are example of object moving in a circular motion. Take for instance the satellite moving around the earth is undergoing a circular motion. And number two, a stone, we say satellite as one, moving around the earth is moving with a motion of a circular motion. Now if you have a stone tied to a string, and then when it's winged vertically or horizontally in a circle, is also undergoing a circular motion. Now, either it's winging right in a horizontal but in a circle, or vertical, still in a circle, is undergoing a circular, uniform circular motion. And also the moon moving around the earth is still undergoing a uniform circular motion. The sun as well, but now the earth moving around the sun is equally moving with a uniform circular motion. Now, these are some objects that are observing or that are applicable to uniform circular motion. Now, this object that is moving with a constant speed in a circular motion, as it's moving with a constant speed, now the direction of the motion is changing in a uniform manner. The direction of the motion is changing in a uniform manner, and as well, the velocity is equally changing, moving in a circular manner. Now, as it's changing, remember we said in the first two classes that we did that acceleration is change in velocity. So if the velocity is changing with time, that means acceleration is directed towards the center of the circular path. So if it is now called the centripetal force. Now, remember I said again, an object that is moving with a constant speed. As it's moving with a constant speed, the motion of the object is also changing in a uniform manner. As well as the velocity of that object. And it's doing that equally, acceleration is equally changing, because remember we said velocity, change in velocity is acceleration. Change in velocity is acceleration, and is directed towards the center of the circular path, where we have A is equals to Vz all over R. A is equals to Vz all over R. Now, A is acceleration. R is the radius of the circular path. The circular path. The V is the velocity. Now, the acceleration is directed towards the center of the circular path, and that's what we call the centripetal force. Centripetal force. Centripetal force. And centripetal force is the force, the inward force. Now remember, moving in a circular form and something like this is a centripetal force. The inward force, we say centripetal force is the inward force that keeps a body moving in a circular path. The inward force that keeps a body moving in a circular path. Now that means Ft is equals to mv squared all over r. Okay? All over r. Ft is equals to mv squared all over r, where the Ft is now centripetal force. Remember I said that symbol is very important in physics. The SI unit, very important. The formula as well, very important. If you combine these three things together, physics become easy as pie. Ft is now the centripetal force. Centripetal force. Then m is the mass. The v is the velocity. And the r is the radius of the circular path. And r is the radius of a circular path. R is the radius of a circular path. So centripetal force is the inward force that keeps a body moving in a constant speed. And it is Ft is equals to mv squared over r. Ft is equals to mv squared over r. And in derivation, the SI unit is in Newton. SI unit is in Newton. Is in Newton. Remember, we have fundamental quantity and derived quantity. When it's being derived, the SI unit for centripetal force is Newton. The inward force that keeps a body moving in moving constantly in a circular motion, in a circular path, is a centripetal force and has a formula. Now, the force that is exerted on the body moving in a constant speed in a circular motion is called centrifugal force. The inward force that keeps a body moving in a circular path is centripetal force. But the force exerted on a body moving in a constant circular motion is what we call the centrifugal force. The force exerting now on the body is called centrifugal force. Okay, let me say two. Centrifugal force. Centrifugal force is the force that keeps a body, that's a force exerted in the body moving in an circular motion. Okay. Centrifugal force. Centrifugal force. Now, the centrifugal force is the force exerted on the body moving in a circular path, experiencing a circular motion. While centripetal force is the inward force that keeps the body moving in a circular motion. So the difference between the centripetal force and the centrifugal force. And that leads us to application. Most of the things we do in physics, it has an application to our everyday lives. Now, the centrifugal force, since a force exerted on the body, moving in a constant, moving in a circular path, has some application. Let's say, for instance, a car turning in a car turning in a corner or in a track. The person sitting in the car is feeling that force. That is why somebody driving a car and is trying to turn. The person is turning, the car is turning, but the person itself is not actually turning, but sitting where he's sitting, because the centrifugal force is being exerted on that person. Another example is someone running a track, let's say track event that has to go around a circle 1 or 2, 3 times. It gets to a point, you sitting and watching the person, look as if the person wants to fall, but the person is still turning, but still in position. So the centrifugal force is being exerted on that person to run through that circle. And a circling, that's a motorcycle or a bicycle trying to bend around a corner, is also feeling the effect of a centrifugal force. A centrifugal force is also being used by a centrifuge in hospitals. They call it centrifuge. Okay, let me clean this part. Centrifuge is being used in the hospitals to separate two liquids of different slight slight in density. Take, for instance, cream and milk. They're both liquid, but of slight different densities. And take, for instance, blood of various different densities. And so centrifuge is used in the hospital to separate such liquid. You know, in the blood there's water also that contains in the blood. So, and they're of different densities. So centrifuge is also used in those places to separate the liquids that has different density. These are some applications of a centrifugal force because they are applicable to our everyday lives. Now, let's continue. A body moving in a circular path is also having an angular velocity and an angular speed. An angular velocity and an angular speed. Angular velocity and angular speed. Okay, we said a body that is moving in a circular path, in a circular motion, also has an angular velocity and an angular speed. Now take for instance a stone that is tied to a string and is winged round as shown below. Let me make a diagram. Let's say, okay, and P, S, and Q, and the V is theta over T. Okay, now, okay, let's say S. Now, remember we said a body that is going around a circle is experiencing an angular, it has an angular speed and equally an angular velocity. Now take for instance a stone that is tied to a string and is winged round in a circular path. It's undergoing circular motion and has an angular speed and equally an angular velocity. Now a stone that is winged round moving from point P to Q, from point P to Q in a given time, in time t, a stone wing from P to Q in time t is so as the radius from P to R is being sustained at an angle theta. Let's say P O Q is being sustained at theta. P O Q is being sustained at an angle theta. Now this, if you compare, and the formula for angular velocity is W is equals to theta all over time, and theta is the angle turned through, and theta is the angle turned through. Then T is time, in an elapsed time. When P, a stone moves from P to Q in a given time, in a time, and so as the radius from P to Q is being sustained at an angle theta. And we said that angular velocity is equal to theta over time, where theta is the angle turned through, the angle that is turned through at an elapsed time. So T is equally an elapsed time. Let me use the word elapse. Elapsed time. Now if I compare this to a linear velocity, if I compare this now, which is W, okay, let me clean properly. W is equal to theta all over time. Let's say 1. And then if I compare this to a linear velocity, which is V is equal to S over T. V is equal to S over T. And I say 2. Let's say V is the velocity, speed. And then S is the length. S is the length from P to Q. S is not the length from P to Q. S is the length from P to Q. S over time, where V is the velocity. S is the length. S is length from P to Q. From P to Q. Then if you compare this also, the angle now becomes angle is equals to S over R. We said theta becomes S over R. S over R, and the theta is representing the angular turn over time elapsed. So related it to linear velocity is V is equal to S over T, where S is representing the length from P to Q. And then Q now, theta becomes S over R. S over R. R is the radius of the circular path. Now if I make my S, so the formula becomes S is equal to R theta. S is equal to R. So if I input this one now into this equation, it becomes, wherever I have S, I put R theta. So V is equal to R theta all over T. S is equal to R theta all over T. And then remember that theta over time is what? Angular velocity. So V becomes RW. V becomes RW, and W is the angular velocity, and it is measured in radian per seconds. Is measured in radian per seconds. V is velocity, or let us say linear velocity, and R is the radius of the circular path. And then W is angular velocity and is measured in radian per seconds. Radian per seconds. That is the SI unit.